Hi everyone, myself Deekshitha P. I am explaining about common source and common emitter amplifier. These are the points I am explaining: introduction, common source, working principle, common emitter amplifier, working principle of common emitter amplifier, characteristics, advantages, limitations, applications and conclusion. First, introduction to amplifier. Amplifiers are fundamental electronic circuits designed to increase the amplitude of power of a signal. They play a critical role in various electronic devices and systems by boosting weak signals, providing necessary signal conditioning, and enabling signal transmission over long distance. Amplifiers are widely used in audio systems, communication equipment, instrumentation, and numerous other applications across industries. Illustration or diagram depict a basic amplifier circuit highlighting input and output signals. Images representing different types of amplifiers such as operational amplifiers, transistor-based amplifiers and vacuum tube amplifiers. Examples: speakers, microphones, televisions. Common source amplifier. Definition: the common source amplifier is a type of field effect transistor amplifier. Circuitry consists of an FET, a biasing network, and input and output coupling capacitors. Configuration: the input signal is applied to the gate terminal while the output is taken from the drain terminal. Working principle: the FET operates in the saturation region, providing voltage gain determined by the load resistor and transconductance of the transistor. Working principle of common source amplifier. Biasing: the biasing network sets the operating point of the FET to ensure proper transistor operation. Signal amplification: the input signal modulates the transistor's drain current, resulting in amplitude output voltage across the load resistor. Gain and linearity: the voltage gain and linearity of the amplifier depends on the transistor, transconductance and load resistor. Common emitter amplifier. The common emitter amplifier is a type of bipolar junction transistor. Consists of a BJT, biasing resistors and input and output coupling capacitors. The input signal is applied to the base terminal while the output is taken from the collector terminal. Working principle: the BJT operates in the active region, providing current gain determined by the load resistor and transconductance of the transistor. Working principle of common emitter amplifier. Biasing: the biasing resistors establish the operating point of the BJT to ensure proper transistor operation. Signal amplification: the input signal modulates the transistor's base current, resulting in amplified output voltage across the load resistor. Gain and linearity: the voltage gain and linearity of the amplifier depends on the transistor's beta and load resistor. This is the circuit diagram of common source circuit and common source waveform. This is the circuit diagram for common emitter circuit. This is the common emitter waveform. Characteristics of common source and common emitter amplifier. Voltage gain: both amplifiers provide voltage gain, which is the ratio of output voltage to input voltage. Input and output impedance: the input and output impedance of the amplifiers determine their interaction with source and load impedance. Bandwidth: the bandwidth of the amplifiers determines the range of frequencies over which they can amplify signals effectively. Advantages of common source and common emitter amplifier. Voltage gain: both configurations offer significant voltage gain, making them suitable for signal amplification. Configurational simplicity: the circuitry of both amplifier is relatively simple, consisting of a few active and passive components. Versatility: common source and common emitter amplifiers can be easily modified and adapted for various applications. Limitations of common source and common emitter amplifier. Biasing stability. Maintaining stable biasing conditions can be challenging, particularly with the temperature variations. Linearity. The linearity of the amplifiers may degrade at high signal amplitudes, leading to distortion. Power dissipation. Both amplifiers may dissipate significant power, especially at high output levels. Applications of common source and common emitter amplifiers. Audio amplification. Used in audio amplifiers and headphones amplifiers. RF amplification. Employed in radio frequency amplifiers and communication system. Instrumentation. Utilized in measurement and instrumentation circuit of signal conditioning and amplification. Conclusion. In conclusion, the common source amplifier stands as a very versatile and valuable circuit in electronic system, offering significant voltage amplification and signal processing capabilities. Throughout this presentation, we have explored the theory, operation, characteristics, advantages and application of the common source amplifier, from its utilization of metal oxide semiconductors, FETs, to its role in audio amplification, communication system and instrumentation. The common source amplifier plays a crucial role in electronics. Despite its advantage, it's essential to knowledge its limitations, including biasing, stability challenges and sensitivity to environmental factors. Engineers and designers can leverage the common source amplifier configurational simplicity and versatility to address a wide range of signal processing needs. Thank you.